Ready? Hiya!
Hi guys!
There we go. Got a few people that are joining us. Just making sure they got the audio. Hopefully everybody can hear us. Hiya!
Hello, lovely to see you back again. Look at all those little waving faces from the Link School. Hi, the Link School.
There we go.
Hello, Imogen on the iPad. Hello, Katie again.
Nice to see you guys.
I'm hoping that you guys have all had fantastic fun making your marshmallow shooters. If you've got one that you want to show us, it would be a great time to see your little marshmallow rocket launchers now.
Checking this. Just quickly alone.
Oh, Katie, loving it. Fabulous. Still waiting for a few people to get logged in and to join us with sound. So bear with us for a few minutes while we just make sure everybody can see and hear us.
Yeah. Oh, no. One more person joining us in. Here we go. They're coming in quick and fast. Hopefully we'll have everybody in.
Hello, Freethorpe School. Give us a wave if you can hear us. Woo!
Here we go. Excellent. So I've got here 3 from Allenby is just joining us now.
We're having
there we go.
An infant class 2.
Yes, we've got infant class.
Hello, Shreya. Give us a wave. There she is. She's like, is that me? Yes, it is.
Yes, it is. It is. It's good to see that I've got everybody. Most people will. Hopefully, everybody can hear us. Guys, don't forget if something goes, you need to type, but you can type in chat. And we've got a team on that will respond to all your questions as well. So if you've got any questions, please type it in. And we do it. So there we go.
There we go. Hi, Kylie.
We'll say hi to everybody. That's one of our team just helping out everybody.
I'm also going to give a shout out to Evie Slater in the audience there. Hi, Evie, and Millicent Bystander. Hello, Millicent.
Cool. So we got a few people, and that's brilliant. I think that. Oh no, there's more. Sorry, just doing the last few bits, but I think what we can do is we can start, and I'll just keep on allowing.
Yeah, I'll keep an eye on it if you like when you're getting started. That's absolutely fine.
All right. So first again, guys, welcome. If you were with us in the first session, welcome back. If you're brand spanking new to the session, welcome, guys, and welcome to Empiribox Science Day, the second one, fun with food. With me, I've got Sarah, the scientist.
Hello, everybody. And we also got our resident scientist, Chris, today too.
Glad to see everybody's back. And today we're going to actually have a bit of fun with food, and we're also going to play with dry ice. Now, we should tell them about the worksheet, shouldn't we?
Yes, we should. So we have provided for you, whether you are in Key Stage 1 or Key Stage 2, a fantastic worksheet, which is downloadable. And if you haven't yet had the opportunity to download that or to print that off, then please feel free, because that has got your starter activity for today's session on it. I can see that Katie is all over this in the front room with her mum there. So fantastic to see that you guys have got that sorted. So you have got a starter today on solids, liquids, and gases, which is essentially what our session is all about.
Yes, so guys, we're going to look and see how a certain substance can change from a solid to a liquid to a gas and back again, depending on whether they heat it or cool. But we actually have a very special solid with us today. I don't know if you guys have ever heard of dry ice before. If you've heard of dry ice, that is basically solid CO2 or solid carbon dioxide. Exactly that what we breathe out. So, you know, we breathe out carbon dioxide. Now we've actually put it in as a solid. So we've got it as a solid form. And it is so cold, guys. It is a minus 80 degrees Celsius. That's how cold it is. So we have to be very careful while handling it. We're going to show you a couple of things that happen with it, with a couple of cool experiments that we've left out. So guys, like we said before, on your worksheet, you've got your start activity. You can do that at your own leisure time. See if you can actually identify what's a solid, a liquid, or gas. Now, we're all going to give you a few seconds to quickly think to yourself, how would you describe a solid? How would you describe a liquid? How do you describe a gas? And then we're all going to act it out, because we want to make absolutely sure you understand what's a solid, a liquid, and a gas. Are you ready, guys? So we're going to give you 2 minutes. Quickly think about it. What's a solid? What's a liquid? What's a gas? In your own words, how would you explain that to your friend or your partner?
I reckon Mr. Burrow's class are all over this. I can see hands up in the air. Yeah.
So give him a few more minutes. So solid, how would you do a solid?
I think I'd do a solid like this.
Yeah, you want to be
quite cold, maybe, but I suppose if you know, we should be quite close together, shouldn't we, as a solid?
Yes.
Which is obviously quite difficult at the moment, but
we're going to see what they think, actually.
Yeah.
Hopefully they would also think about, well, if the solid's very close, what do you say the gas is then?
So if they're a gas, I guess they'd be further apart.
You never know. We'll quickly
be more like a gas.
Yeah, we'd probably be more like a gas.
Actually, maybe this would be like a gas.
You're going all over the place. Don't forget you've got to run all over the one pace. All right, boys and girls. Now, if you've had a chance to think, I know I didn't give you a lot of time to write down, but we'll quickly go through those steps just to make sure that we all understand the differences between a solid, a liquid, and a gas. All right, so let's start with the first one, a solid. Now, boys and girls, if we had to have the biggest, most amazing microscope and we can zoom into everything that's around us, we know that everything is made up of particles. Now, in a solid particle, so if we look at a solid, something that's described as a solid, all those particles are extremely close to each other. So they're so tightly packed. And we know from that shape there that they are a solid. If we look at a liquid, the particles are a little bit more further spaced between them, or they've got a little bit of a bigger space between them, and this allows them to flow. And then the last one of the most beautiful things ever is a gas. See, a gas has got no bonds between them. It's just a load of space, which means they can walk and go wherever they want to, all around the room. And that's what makes a gas so amazing. Now, we told you guys that we've got a very special solid with us today that is actually a gas. And that is my dry ice, which we stored in this little container here.
Why is it in the container, Chris?
Well, the reason why it's in the container is because it is such a cold substance that we actually have to have protective casing for it, because it can actually hurt your skin if you touch it. So that's why we're going to use tongs and a lot of other things to help us with this. Now, the first thing I'm going to show you guys is just to show you how amazing dry ice is. If I've got a little bit of dry ice, I'm going to put it inside my bowl. Hopefully Sarah can bring up the camera too.
Did you mention how cold it is, Chris?
Yeah, yes, I said it's minus 80 degrees. Now, boys and girls, there's my dry ice right there. I'll bring closer to the camera and everything like that so you guys can see it. But you know what's amazing about dry ice? I can make it scream. I can make it scream. Yes.
That was me. That
was Sarah. No, it's not the ice. Guys, so all I've got is a spoon, a little bit of dry ice, and you can hear, I'll go very quiet now. Oh. Oops.
Can you hold it higher?
Yeah. Oh. If you guys can hear, hopefully you can hear that.
Lift it higher, Chris.
Oh, sorry. Oh, no. Well, guys, it will actually start to scream if you go back to number one. And the reason why this dry ice starts to scream is because it's so cold that suddenly when I bring in that teaspoon and I touch the dry ice, it goes from a solid and it jumps straight to a gas. It doesn't even go solid, then liquid, then gas. No, it jumps straight ahead. So it goes all the way from solid to gas. But because of that rapid amount of release, the bubbles that it creates, basically the gas, start to vibrate and then make a noise. And that's why you can actually hear it scream. Now, I don't know if it's going to work with my tongue, but last time I did it, it screams like mad. Now, one of the most beautiful things that I love about dry ice is what happens when you put dry ice into water. Now, the first thing I'm going to show you guys is my little flat bottom conical flask right there. And what I'm going to do is, if I move this a little bit to the side so you guys can see, inside is only cold water. So look what happens when I suddenly put dry ice inside this here and see what happens. Just see what happens. Just imagine what you can see is happening. Now, you guys can see it starts to bubble, it starts to smoke and everything like this. Now, that is actually because the CO2 is being rapidly released. It's changing from a solid into a gas, and that is what you can see here. It is so amazing. Now, I told you I use cold water.
Hold up there, see if you can see it.
Yeah, you can probably see it a bit better there. Now, guys, this is what you can see in this point. It's that rapid release. But what do you think will happen if I suddenly start to use warm water? What do you think will happen if I actually replace that? We take all of that out. Yeah, there we go. And I'm going to use hot boiling water. So let's see if that will make a change to it. So if I put that in there, I fill it all the way to the top. Then I'm going to add my dry ice again. And look at that. Guys, can you see a difference between when I had cold water versus what I've now when I've got hot water? So why do you think that? Why do you think if I use cold water, the bubbles are just like, yeah. But the moment I've got hot water and I've got it in there, you can see it suddenly just boiling over, steaming so much, changing from that solid to a gas rapidly. What is the difference between the two? If you said temperature change, you are absolutely right. If it's warmer, it allows my solid to change a lot quicker than it was cold. Think about it. If you're in the morning and you're cold, do you want to move out of your warm bed? No. But the moment it's nice and warm, you're up, you're ready, you go like, yes, I'm ready, I'm going to do all of that. Same thing happens here, boys and girls, and it's so beautiful to see. Now, we can extend onto that. Now, I can take all of that smoke I've created there.
So why is the smoke falling down there?
Oh, yeah, that's a very good question. Why is the smoke falling down?
I don't know. Can you guys think of a reason why it might be going down? Why isn't it lifting? Normally when you have a hot kettle or something, the steam rises, doesn't it? Do you think why it might, in this instance, be falling onto the table and down the front of the table?
Well, remember what it is made up of. It is made of, well, Kevin, almost, you think about its gravity, you've got it in a certain degree correct.
Yeah.
But it is made of CO2 or carbon dioxide gas. And for those people who don't know this, carbon dioxide gas is actually a heavier gas than air. So that's why it will go down and it won't go up as you think about it. But I can make it go up.
Yes.
I can.
Yes, you can.
But all I need to do is, again, I've got my little bottle here and I've got warm water in the bottom. But this time I'm going to build up the pressure by putting up a sports cap on it so that I can, let's see if I can get it in there. Yeah. So I can make sure that it goes in a direction that I want it to go. There we go. Just popping the guys in there. Few more. There we go. Just make sure it goes all the way. Oops. There we go. Now there's boiling, guys. I'll put my little steam cap on. And you can see immediately I can make the gas. Oops, sorry. Did I go a little bit too high? I can see I can make the gas squirt out any way that I want. So now here's my little mystery that I've got. So it just shows you I can actually increase the pressure of this bottle by making the hole smaller. And look what happens. It squirts and goes almost everywhere that you can see here. So dry ice is such an amazing product. And we use it almost in a lot of places. We actually do. But it's so much to see this amount of fun that we can have. But this is not the only thing that we can do. Sarah, tell them, what else could we possibly do?
I reckon that you could catch the gas that's coming out of the...
Oh, I can, yes, definitely. I can possibly capture gas. But to capture the gas, I'll need to make sure I've got more dry ice. And this time, Sarah, would you mind helping out a little bit? I need someone to hold on to the bottle for me.
Well, I will hold the bottle. There we go. Whoa! There we get it on. Hang on. I might move those out of the way.
And it will probably pop.
And it's gonna go! It's gonna go!
So it just shows you how much of the gas I'm capturing, and it will keep on continuing.
Oh, my life.
And here we go. It pops off and it goes almost everywhere. All right, guys. So number one piece.
Yep.
Here we go. Fantastic. Now, Sarah, what do you want to show them with these coloured ones?
Okay, so you might have noticed that we've got some very exciting coloured measuring cylinders on the front here. So all this is just coloured water, and then I've added a little bit of washing up liquid into this as well. So I want you to have a little think. Do you remember we were talking about predictions in this morning's session? Just have a little think about what do you think will happen if I put dry ice, which you've just seen bubbling and fizzing away and stuff and popping over the top. What do you think will happen if I add dry ice into the top of my measuring cylinders here? So have a little bit of a think about it. Discuss it with parents or with your teacher in the classroom.
There we go, and see what happens.
We will give it a go. Oh, Mr. Young's class reckons that we are going to get bubbles. Okay, so let's have a go then and see if Mr. Young's class are indeed correct. So here we go. Pop my dry ice into the top. Oh, it's going to be messy.
Do you want a number 2?
Yeah, let's go number 2. Hang on. Camera control.
Look at that, boys and girls. So again, the dry ice is reacting with the water, but this time we are capturing the gas in the bubbles in the fairy liquid. And you can see if I start to poke at it, it starts to release the gas bubbles that you can see there. So it just absolutely, Hannah and Harith.
It looks like a volcano, yes.
It does look like a volcano, it does. But look at how colourful we can make it. And the fascinating property, again, is how quickly that CO2 gas changes from a solid all the way to the gas. And this is this rapid expansion that you can see here. And it will continue, will go, and will go, and will go for a very long time. And we absolutely adore this. We love it. This is one of our favorite things to do. But we don't stop there.
No, we can. So we have had to go here at creating loads and loads of tiny little coloured bubbles. And I reckon that we can go one step further and create like a massive bubble. Okay, so we have got our water in our bowl at the front here. Thank you very much. And then I've also got a washing up bowl full of just some normal like fairy liquid, the kind of thing that you wash your pots with at home, with a little cloth in there. And what I'm going to do is I'm going to pour my dry ice into the water. And we know what will happen. It will create loads and loads of bubbles, won't it, as the carbon dioxide turns into a gas. And then I'm going to swipe my cloth across to create a big bubble, and we'll see how big it gets. I reckon we probably want to go on to view 2 for this one.
Yeah, absolutely.
Right, are you ready then, guys? I never know how much to put in. It's always very exciting.
No, put it all.
I'm going, oh, we're going crazy. Going crazy. Chris, if he's given me permission, it's not my fault if this goes wrong. So we're dumping in. Ah!
There we go. Now watch very carefully.
Getting my cloth. Going to create a big bubble over the top. Oh, it's going for it. It's going for it. Hang on. We might need that a bit wetter.
Yeah.
Oh. Hang on. We love it when science goes right.
Yeah, no, don't worry. Just give it a couple of seconds.
Oh,
there we go.
There we go.
Look at that, guys.
Can you see that bubble going?
Now,
Chris could do something really awesome here because he's going to have wet hands. Oh, it popped before you got a chance. So create another bubble. Get your hands. Oh!
There we go. Another bubble.
You put his hand in the bubble, look.
Almost. Let's see if I can do it again. There we go. Now, guys, if your hands are nice and wet like mine, you can actually stick your finger in. Nothing will happen. And you can make it pop that way as well. So, boys and girls, what we can show you here is we can actually capture these bubbles and we can use them for our own benefit. Now, it can be where it looks like it's going absolutely mental, as you can see with all the fairy liquid that we've got here, and it just continues to go all the way through. But not only does it look visually fun, but we can use this, or we can create basically something that is edible. So yes, we can actually create something that's edible. Now, Sarah, would you like to show them how we can create ice cream?
I would love to show you how to make ice cream. some of you guys might have made a similar version to this at home if you have had, or at school if you have joined in with Empiribox boxed up lessons. This is similar to one of our sessions that we've given you guys to have a go at schools. So what I'm going to do then is I'm going to take a very little plastic bag here, and inside of my plastic bag I am going to pour a small amount. I'm not going to go mad here because otherwise me and Chris will just get really, really fat. So I'm going to pour a small amount of milk into my little bag there. Chris, could you hold that for me?
Of course.
Please? Thank you. And then I'm going to add some double cream, because who doesn't love double cream, you know? So here we go. I'm going to add some double cream into my bag there. Fabulous. Now, this is the really important bit. You need to seal the bag, okay? Because what we don't want to do is to get any of our dry ice into our mixture of milk and cream here. Now, if I wanted to, if my favorite flavor of ice cream would have been strawberry, I could have had strawberries in here. What's your favorite flavor?
Chocolate.
Chocolate. I could have added chocolate in here. I could have put lemon in, all kinds of things. But what I'm going to do, look, is I'm going to put this bag with my cream and my milk into the big bag, okay? And now I'm going to use some of those freezing properties that we've just seen of the dry ice. So I'm going to grab some dry ice, and I'm going to make sure that I put my safety gloves on for this, because as you have seen, dry ice is super, super cold. And I don't want my fingers to get down to minus 80 degrees because they'd be falling off at that, wouldn't they? So I'm going to put my dry ice then into the bag.
This what?
Oh, go on then, why not?
Yeah.
Let's go crazy. And now all I'm going to do is I'm going to squish all of that cream and milk around with the dry ice in the bag here. Give it a good squish about. I need to make sure that I'm not squishing too hard, because what I don't want to do is to pop the bag inside with the milk and the cream in it, because that would be a bit of a disaster. However, me and Chris were discussing earlier on that they do use dry ice in some of the bars and restaurants and things in town now. So if you ever see like a cocktail and you're seeing like all of the gases spilling over the top of the cocktail there, that might be, or is likely to be, dry ice that they are using. And obviously, if you got that in your mouth, that would be very, very painful. So we need to make sure that we don't get any of the dry ice in the back there. Okay, so taking some time to go. Keeping squishing it around. I'll tell you what, I'm pleased I've got my gloves on. It's a bit chilly. Look what's the flavor in.
Almost there.
Oh, we're still a bit liquid there. We're still a bit liquid. I'll tell you what, I am going to leave Chris to agitate that a little bit and see if he can get our liquid to turn into a solid whilst I run through your practical for the session. So this morning we gave you a practical which was to make a little marshmallow rocket launcher, didn't we? And I've seen loads of your fantastic rocket launchers. Some people were waving them around at the start, and I hope that, you know, nobody accidentally sent a marshmallow in the direction of a parent or a teacher, because that would be, you know, terrible. So what we're going to have a look at now then is how you guys can do your own version of this. So I know that you haven't got dry ice at home, but you know what? You don't need dry ice in order to make your own version. Now, rather than doing ice cream, we have decided that we're going to show you guys how to make a delicious sorbet. So I don't know if you know what sorbet is, but basically sorbet is like a fruit. Imogen knows what sorbet is. She's like, yeah, I know. So sorbet is like a delicious icy version of, oh, Kylie says she'd like a lemon one. I'm sorry, Kylie, but I haven't got lemon for you today. I have got orange, okay? So you can use any kind of fruit juice for this. So I'm happening to use orange, but if your favorite is pineapple, you could use pineapple. If you like grape, you could use grape. You could use apple, pear, whatever your favorite is. Orange is yummy, absolutely. Okay, so in the same way that we had 2 bags earlier to make our ice cream, you guys are going to need 2 bags of different sizes to make your sorbet, okay? Now I have got 2 bags, these different sizes. It doesn't matter. They don't have to be exactly the same sizes as this, as long as you can seal the small one, okay? You do not want to get anything else except for your sorbet into the little bag. So you know at home, if you have got like one of those freezer bags with like a Ziploc on it or something, or even if you haven't got one of those, if you've got like a plastic bag and you can just put a really, really tight knot in the top, that would work too. And then you need another bag, which is a bit bigger, and that could be a carrier bag or anything. It really doesn't matter. You don't have to seal that one, okay? So I'd like you to take your little bag. Oh, has it worked? Oh my life. Are you gonna, do you want to get spoons and we'll have a little taste of that in a minute?
Yeah.
Fabulous.
I'll keep it cold.
Keep it cold for me. Put it on ice.
I will.
Okay, so you're going to take your little bag and your carton of juice. And this is where I realised that I probably should have pre-prepped this earlier so that it wasn't a disastrous mess, which is probably going to be now, especially with my gloves on. No, we're all good. We're all good. So far, so good. Okay, so I'm going to put into my bag my fruit juice. Okay, so there we go. Now, the amount of fruit juice you put in, I reckon depends how hot a day it is and how greedy you're feeling. I'm just going to go with a little bit, but you can go crazy with yours. You could mix flavors if you wanted to and go really crazy with it. So, as we said, this bit is super, super important. Make sure you seal that bag, okay? Because what we are going to do now is we're going to put this into our big bag. Oh, he's so good, isn't he? So all kinds of helpful is Chris. There we go. So in the big bag, Chris has put just some regular ice cubes, you know, out of your ice crate, ice box at home. And then we're going to put some salt in here as well. Have a little bit of a think between you what you think the salt will do with the ice cubes. Okay, so make a bit of a prediction. What do you think will happen? Tie me a little note out at the bottom if you think you know what happens. Send us a note, Imogen, because I can't hear you in your reindeer ears. So I'm going to put my lemon, no, it's not lemon juice, it's orange juice. Oh, Mr. Young said it helps it to freeze.
Yes, it actually lowers the melting point of water, which means it will actually become colder than what we think it would always be. And that's what helps you with your sorbet. Now, boys and girls, exactly what we've done with our ice cream is what you're going to do. Now, the trick is keep on agitating it. Keep on agitating it. Remember, but make sure that you've got gloves on, you know, shake it a couple of times, make sure that way, so it gets covered around the ice and it will help it solidify. So it changes from a liquid into a solid. So because we are freezing it, we are making it colder. You saw we've got something cold, we changed into a gas pipe, giving it heat. That's the little trick that we've got here.
Okay, so I'm going to carry on agitating this. Now, I'm just going to give you a very key tip or trick for this. So when you have finished and you've noticed that your sorbet inside is no longer a liquid, so it's not all kind of runny anymore, and you can see ice crystals forming, and it looks like something that you'd really deliciously like to scoop out with a spoon and consume, make sure that when you take the central bag out, the middle bag, you rinse it under the tap. Because what have we got in the big bag? We've got ice and we've got salt, haven't we? So there will be salt on the outside of your bag. And trust me, orange and salt sorbet is not that delicious, okay? So just make sure that you rinse that in a bag before you dig in with your spoon and try your sorbet, okay?
You don't need to do that one.
Thank you very much. Yeah, I will say, okay, so this was ice cream earlier on, wasn't it? So can you remember? So we've got our dry ice in the big bag, and then in the little bag inside, we had our, I'm losing the powers of speech.
Milk and cream.
Thank you, Chris. We had our milk and cream. I am just going to remove my glove. There you go. Thank you.
No worries.
Are you loving the fact here that Chris isn't trying this ice cream? So if anybody dies, it's going to be me rather than Chris. I think we should get him to try the sorbet, which, as far as I'm concerned, is slightly riskier because that could have salt on it, couldn't it? Okay, so can you see now that my ice cream, look, it's a solid. And hang on, I'm going to give it a go. So ice cream, made with dry ice. It's delicious and very cold.
And
How's that sorbet work?
I think so. There we go.
Yay! Fabulous. So here's our sorbet look, guys. And you can see it no longer pours, so I know that it's not a liquid anymore. It's now a solid, isn't it? And this is really, really delicious to eat. But don't forget to rinse the bag before you open it and take a big spoonful. Otherwise, you'll have a salty sorbet, okay? Right, so I hope that you have really, really, really enjoyed our Science Live day today. We will hopefully be doing more of these in the future. We've done a few in the past and they're getting more and more popular all the time. I think we had, I don't know, a few hundred people today tune in, and it's been fabulous to see you, and numbers will continue to grow. So hopefully we get to see more of you. If you've enjoyed our science experiments as well, have a think about looking on the Empiribox website and see what else we've got available for you. We've got some fantastic options for our boxed up service and loads of other things to do as well. And we have just recently had a competition.
Yeah, boys and girls, ladies and gentlemen, I don't know if you guys were paying attention to a competition that we were running basically for our scientist superheroes. So we asked a lot of schools, you know, we sent it out on the ether with social media, everything, and we had so many responses back. And today we would like to announce the winners of the competition.
Shall we tell them what the prize is?
Well, no, we will first winner, then we get prize. All right, boys and girls, so I'm going to talk about the runners up. I'm going to show you some of the things. So I'm going to quickly share my screen so that you can see what we've done.
We had thousands and thousands of entries for this, so we couldn't show them all, unfortunately. But here are some of our favourites.
So, guys, Superheroes of Science, the competition winners. So if I go, oops, sorry, let's make clear, so I click on it. There we go. So we asked you guys to look at our superheroes. So we've got Billy the biologist, we've got Cara the chemist, and we've got Phoebe the physicist. And we asked you guys to give us a few indication of what they would look like with their superpowers and everything. And we had so many entries. So on this web, this PowerPoint presentation I have, boys and girls, ladies and gentlemen, I did not put every one, or else we would have been here for several days by going through each one. So we just put some of the ones that we really, really loved. I thought they were absolutely excellent. So boys and girls, those who are signed in, if you see who you are, the ones you've got there,
have a little celebration in your classroom if you're seeing your work up on the screen.
So you can see how much we've done, guys. We looked at each and every single one. We had days where we were sitting and checking them out and everything. It was absolutely fabulous. And you can see all the wonderful things that we've done there. Now, boys and girls, as we go through each of them, now it's time that we actually need to say who are our winners. So if I move on a little bit faster, I think, there we go. So our runner-up for Billy the biologist was, if I'm correct, it's Emilia from Mile Oak Primary School in Brighton. Emilia. And I do apologize if I pronounce the name incorrectly, but I'm going to say it's Egan or Egan. Ian,
well done.
St. Patrick's Primary School and County Down, Northern Ireland. So well done, boys and girls. You guys are absolutely fabulous on that one. Now, we also need to talk about who is the winner. And the winner for Billy the biologist was, and here we go, Bugman by Izzy from Oakfield, London.
Yay, well done, Izzy.
So well done, Izzy. Congratulations for being the winner for Billy the biologist. But we're not done yet. We've got our runners up for Kira the chemist. So that would be Niall from St. Patrick Primary School as well. And we've got Renisha from Dairy Meadow. Well done, congratulations.
Yay!
You guys are fantastic. But the winner for this one, or this competition, was, it was definitely Elle from Freethorpe. Well done in Community Primary School in Norwich. We absolutely loved Radical Reaction, and the winner that we've got here, she was absolutely successful. We loved it. You guys made you made our days.
Oh, have you seen a weakness on the...
Yes, anomalies and freezers.
Anomalies and freezers.
Now, guys, for a run-up for Phoebe the physicist, we've got Saitan Sheeta from Dairy Meadow, and we've got Driti from Dairy Meadow as well. Well done, guys. Very congratulations on that. And the winner of Phoebe the physicist is Lila or Leela from Eastlands, rugby. Well done. So
Yay! Well done,
guys,
Lila.
again, thank you so much for this wonderful things that you guys have sent to us. So well done to everyone. We absolutely loved it. Now, Sarah, would you like to tell them what special scientist or what prizes they will be getting?
I would love to tell you what the prizes are. So if you were selected as one of today's winners for our superheroes competition, our design team are busy making your superheroes into absolutely fantastic framed digital versions so that you can have that at home or at school and display your fantastic work that you have created for us. Now, if you were a runner-up, you will be sent one of our fantastic Empiribox goodie bags. Ooh, I have no idea what's in the goodie bags, but I'm sure it's very, very exciting. Now, if you were one of our amazing winners today, then we have got for you an entire box with fantastic electronic data loggers in here for you to use in your classrooms. So the data loggers here are electronic pieces of equipment which have probes in them to allow you to do your science experiments with a little bit more precision. So you'll be able to put your probe in, and instead of just using a thermometer, it will tell you, what the digital scale is, and you'll be able to have masses of fun with these in school. So well done to everybody who not only was a winner or a runner-up, but everybody who entered, because we have loved looking through all your entries over the past few weeks.
Now, boys and girls, yes, these data loggers do not only record temperature, but they record light, sound, darkness, everything you can imagine they record. So they will be sent to the winners. So again, congratulations to them. We're super proud of you guys. We hope that you had a lot of fun looking at what we've done and how the mess we've been with dry ice. Now, you can probably see, and I'll show you what happens. See, this is what happens to dry ice when you play too long with it. It literally is stuck in my bowl now, so I'll have to unfreeze that later on. Well, boys and girls, mums, dads, parents, teachers, everybody that joined us, thank you so much. Thanks for everything.
Have a fabulous time making your sorbet, guys. Send us your images on social media because we love to see what it is that you've been doing. Oh, let me get a round of applause for a free thought. Thank you very much, guys.
You've got to thank you. We can get the link to the recording. Yes, absolutely. Yeah. The link and of the recording will be sent. It will also be made available on our YouTube channel, so you guys can watch it over and over again. So you're more than welcome to look at it. Thank you so much, guys, for joining us. We hope you've got a wonderful summer holiday coming ahead.
And that the weather improves so you can sit and have your sorbet in the sunshine.
Oh, yes. Well, I'm going to have my ice cream, so I don't know about you guys.
Thank you, guys. Bye.
I'm enjoying my ice cream. I could do with sugar.
Yeah, it's a little bit creamy.
It's a little bit creamy, but not bad.
But I didn't want to. I'm already getting a little bit.
Yeah, you don't want to do too much sugar. So, guys, thank you so much for joining us. All the best, guys.
Have fun. Enjoy your summer.
Let's see. Well done. Thank you. No worries, Katie. Yeah. Thank you so much. We hope you've got a wonderful time as well.
They've got the bottle of orange juice ready, look.
Oh, look at them.
I know.